Hello everyone and welcome to another video tutorial. Today I'm going to continue to talk a bit more about shaders. I just want to make a small disclaimer here. Just to be clear, I know very little about shaders, but I like to learn by trying and testing and playing with things, and in that process I learn a lot. So I hope that by sharing what I learn you can also learn a few things. I did a short poll on the Facebook group and I understood that majority of people will be interested in learning more about shaders. So I'm just going to do something very simple, but hopefully you'll get some ideas on how you can explore also by yourself and learn a few things by yourself. So this time I loaded our Suzanne, for those of you familiar with Blender, a very famous character. And we're going to play a little bit with some shaders with Suzanne. So I'm going to start by creating a new shader material and again a new material shader graph. So we go back to the visual shader. By the way, I'm using Godot 2.1 is the current development version, so probably you'll find a few things that are different from your current stable version, namely the graphics, these icons, the colors, the panels, everything is so cool in this new version. You really have to try it out. Okay, so let's begin by doing something simple. One thing I'm really used to work with Blender to create a lot of stuff with Blender, and I use a lot of nodes to create shaders in Blender. And many times when we are creating shaders in Blender, to understand what a particular node is doing, we connect that shader to the output and we see what kind of information does it contain. You can do that exactly the same way here in Godot. For example, if I want to know what normal input socket in the fragment shader is doing, I can connect it to the diffuse, which is basically the color of the material. And so immediately I see what information is here. Of course, the diffuse output socket is expecting a color, as you can see by the icon, and this normal is just a vector. But the color is what? RGB, red, green, and blue, is essentially a vector of three floats. And the normal is exactly the same, but instead of RGB is X, Y, and Z. So what it's doing is mapping X to red, green to Y, and blue to Z, right? So what is a normal? A normal means when you look at a mesh, the normal is basically the perpendicular vector that comes out of a face, okay? That makes 90 degrees with that face. So the problem with the fragment shader that we are using is that the normals are not the normals of the mesh, but the normals of the pixel according to the camera. Okay, I hope I explained this correctly. So what does it mean is that all the faces in the mesh that are facing towards the camera, or all the pixels that are facing towards the camera, will have the blue color, right? Because blue is what? If you look at the coordinates in Godot, blue is Z, Y it's green, and X is red, right? So back and to the back and to the front is the Z, is blue. So front means blue. So all the faces that are facing the camera are blue, right? So you see this green here, it means it's facing up because our y-axis is green. So if I go up, now it becomes blue because I'm facing it directly. So it's like this becomes the front, so it's blue. Okay, so these normals in the fragment shader are the normals according to the camera position, not the normals of the mesh. So this is interesting. How can I get the normals of the mesh? Okay, I want that the blue stays to the front and the green stays up. Even if I rotate, I want that. Okay, so this I cannot get in the fragment shader. I need to go to the vertex shader. But the problem with the vertex shader is that it works in a slightly different way, and I still have to explore. Also, I'm not I don't have so much experience working with the vertex shader yet. And if I connect the normal to the color, you don't see any output. So there are things here that are not that simple. What I want to do is I want to use this normal information, which is the correct normal information for the mesh, in the fragment shader. And so I just discovered recently, and I'm sure probably many of you already know this, but for those who don't, you can pass information from the vertex to the fragment shader by using these var1 and var2 sockets. So if I connect the normal to var1 and then I go to fragment shader and I have input var1 and var2, now I connect it to diffuse and now I have my normals that will stay always the same regardless of where the camera is looking at. So I have my real normals. Okay, so blue means front facing, green means top facing, and red means sideways to the right. Okay, so with this we can start playing a little bit. Let's say, for example, that, and I used this technique very recently in one example that I posted on Facebook to create some reflections using a fake Fresnel effect. Let's say, for example, that I want to color this monkey face in a particular color, but I want the tops of the eyebrows and the head to be in like a darker brown color. Okay, so we have these two colors and we have to do this with a shader. How do we do this? So let's first create our basic color. I'm going to add a RGB constant. Let's make it like a monkey face color. Maybe something like this. Let's try it out. Okay. So I want this to be the basic color, and now I want to put a darker brown on everything that goes up. The top of the ears, top of the head, top of the eyebrows, etc., top of the nose. So we can use what? We can use the normals, because I know that when the normal is facing up, I want to color it differently. Okay. So in Blender, how would you do this? You use a mix node. A mix node takes two inputs, and according to a factor, it puts either one of them or the other. So here we don't have a mix node, but we have exactly the same thing with a different name, which is called vector interpolate. So this takes two vectors, and then we have the factor, which is going to basically decide how much of each we are going to output from here. Okay. So now let's add our second color. Let's make it a darker brown, like this. Let me just try and check if it's okay. All right, could be. So now I'm going to connect the darker brown here, and the other brown is pale brown here. And the result is going to be our color. So right now it's 0, our factor is 0, so this color is in the maximum. If I put this halfway, then we have half of each, and if I put it in the maximum, we have just 100% this and 0% of this. Okay. Now, if we mix it in this way with a static, constant number, then we get just a solid color all over. I want to use this, I want this factor to change according to the normals, right? So the normals are coming from var1, from the vertex shader. So what I'm going to do, I'm going to split it up into scalars, into numbers. And now I can say that I want the tops to be brown. How do I do that? So I want the top is what? Top is green, right? And green is Y. So red, green, blue. Whoops, something happened here. Must be one of those crazy bugs. Okay, red, green, and blue. So green is here. So if I connect this green here, means when green is stronger, we're gonna have more brown than this. Let's try. There you go. So now the tops are shaded with the darker brown, and the rest there is no green, so it's the original color. Now let's say I want this brown a little bit more strong, not the color, but I want this to be a little bit more stronger. So what I'm going to do, I'm going to change the value that comes out from here so that this grows faster. Okay, so I'm going to use a scalar operator before it goes to this factor here, and I'm going to multiply it by, let's say, 1.2. Okay, so you can see it's darker like this. Okay, so now we have like a hairy monkey. Of course there is hair in the eyes, but never mind that. Okay, so this is a simple example on how you can use all these things to create the shaders. Now let's play a little bit more. Let's use the normal from the fragment shader. So again, this normal is related with who is facing, or what pixels are facing the camera. So let's say, for example, that as I rotate this, these colors get they are static like they are now, but I want to apply like a reddish tone to whatever is facing the camera. So for that I can use these normals, right? So let's create another color that I'm going to use for this. Could be something like this kind of red. And I'm going to create another mix node, a vector interpolation, between what comes out of here and this new color. And this is going to be the final output. Okay, so now we want to use this normal. So let's again split it up. And now what we want faces that are, or pixels that are facing the camera. So we want the blue, right? Blue is Z positive, facing the camera. So red, green, blue, it's Z. So Z goes here. Okay, so now we have a lot of red, but look, as I turn around, you see these faces are not facing the camera at all, so they don't get any red. See? So now we can tune up a little bit the value that comes out from here. So let's use the scalar operator to change or to work a little bit this value. I did some trials before, so I'm going to use a power of 2 here, okay, or let's say power of 3. So you can see the effect that you get. All right, the other way around, the red gets much more spread out to the other areas. Okay, so this was a simple demonstration. Now we are doing here a mix of these two colors, which means that when this is really high, then everything gets red and I lose the detail there. So instead of doing a mix, we could do a kind of add. We're going to add this color to this color. Okay, let's try that out. How are we going to do that? We cannot do an interpolation. We have to add vectors, right? So we do a vector operation. We're going to add this vector to this vector. So now I'm adding these colors. Let's put this back in the original state. Now what I want here is I need somehow to control the intensity of this color according to what comes out from here. Basically that's it. Okay. How am I going to do that? What comes out of here is a vector. So I can just use a vector operator. No, sorry, not the vector operator. Whoops, oh god. Somehow, okay, where are we? Okay, here. We need a vector plus scalar plus vector operator. This is what we need. Because we're going to multiply this color by a scalar, which is going to be the blue information from the normal, right? And this is going to be added there, like that. So you see now that the reddish tone is being applied, but I still get the tones darker on the top of the head. So now let's increase this. And now this is add operation. So if I add more whitish color, I get more light in. If I put black, there's nothing being added. Okay, so let's make something like, okay, like this is nice. Whoops, there goes my shader. Okay, let me just resize. Okay, so now you see everything that's facing the camera gets a little bit more reddish. Not facing the camera gets again to the default beige or brown color. So this is just a simple example on how you can use these values, how you can use vector operators to play around with this. So it's really a lot about playing around, especially, I know, if you are like me, you're learning, so you're doing a lot of mistakes, you probably don't know what many of these nodes do, so you really have to play around to learn. And it's really easy to learn in this way. You have to make mistakes. So let's give it another try, and I hope it's not getting too long. Just if you want to learn a little bit more, let's do something a little bit more dynamic. Okay, let's do some kind of animated glow emission thing. Okay, so we have our emission, which is a vector, which I think should be a color actually, but somehow it's a vector here. Anyway, and we have a glow, which is a real number, means a float. So basically, if you are familiar with the materials, the fixed materials, the glow, I think goes from 0 to 8 or 0 to 4, something like that. So after 1, you already see it glowing. Okay, so let's just give it a try. I'm going to use a scalar constant and add it here to the glow. Now what happens, I cannot see anything because I don't have a glow in my scene. So I need to add a world environment. And let's add the glow. Okay, I think this should be alright. Okay, you see I have my glow now. So I can reduce this glow to 0.2. Or, now let's go to the interesting thing, let's make it dynamic. Let's make it glow and let the glow disappear and appear as time goes by, like it was flashing or something like that. So how can we do this dynamically? Well, we use the time. Now time works in seconds. So basically this is going to be 1, 2, 3, 4. So after some time this is going to go to the maximum and then there. Okay, and then it stays like that forever. So we need to make this a cycle. How we make this a cycle? We use mathematical functions. So I'm going to use a scalar function, and the sine function is perfectly fine. So what happens with the sine function? Whatever number comes from here is going to be outputted something between -1 and 1 all the time, right? So this gives us a cycle between -1 and 1. Let's see it. There you go. And now it looks like it stopped, but actually it's going to restart again. Why does it look like it stopped? Because when the output is going from 0 to -1 and from -1 to 0, negative numbers don't really matter for the glow, so it's kind of just disappears. So what we want to do is to make sure it stays constant all the time between 0 and 1, not between -1 and 1. So for that we can do several things. One of the easiest ways to do it could be to convert this into an absolute number. So like this, and I have my glow always glowing. Okay, it's quite simple. So okay, I guess for today let's finish here. I think there were quite a few things. Just go and try it for yourself. It's really fun to try these things out, and you don't need to set up any special scenes or whatever. Just need an object and a mesh and start playing with it. If you want to use the glows and stuff like that, don't forget the world environment, or else you won't see them, right? If you have any questions, just leave it in the comments, and bye bye, thanks for watching.